one important question related with like machine learning, and because it's really useful for when you're training your model to calculate your loss of your model, for instance. And this model can be a neural network or other kind of more simple model. But why we square the difference on the mean square error? What it means, like so why we do this with this operation here? So when we have, let's say, the ground truth of your training data, and symbolized here by y, and the prediction of your model, so why we square this difference? So the first reason, and that's usually what people answer, is that we do that because we want to have only positive numbers coming out of this equation. And that's true, but there's also another important property that we are going to check here. So let me just copy and paste here code. Let me just plot it. It's basically the function for both the absolute value of x in this range here, -2 to 2, and the second plot is the x squared. And what I want to show here is, as we can see, it's true that no matter what the x is, the y is going to always be a positive number, and that's really great. But another important property is this difference between this linear and progressive relation here of the best absolute value versus this exponential value here. So let me just like reduce here the range only for the positive part of the function, and to make it more clear. So why we do that? So why we use the square? Notice that when we have as a smaller input, like in this case, let's say a smaller difference between the ground truth and the output of our model, we are going to have only smaller values on y. Maximum 1, let's say, when you have like you're going through maximum 1, like difference maximum 1. And that's great because in this case we are, let's say, penalizing less the learning, like the loss is going to be less. But when we start to increase the x value here, our value is starting to get really large. So like for 2 we have like the double of it, for instance. And that's really important because it kind of simulates what we have in reality. Like when we are learning something, if we make like, small mistakes, it's okay. We are not going to, impact our learning too much. But if we are doing really some bad things, like we have great errors, we want to, to correct more our path to learning. So that's we want something to say, hey, you're going to the wrong path big time. So let's adjust that. So that's exactly what we are interested here. So, and basically that's it. So it's really simple. Like we use the square on this really, common popular function to calculate the loss, especially for two properties. One, the one that you probably already knew, that we have like only positive values coming out of this beautiful equation here, and also to impact more the output of this function when we have greater values of like greater difference between, let's say, your ground truth and the prediction of your model. I hope you enjoy it, and that's it. Thank you for watching. See you in the next video. Bye.